This is Svetanka Hristova, and she is preparing for her last attempt at the 1991 World Championships in discus throwing. She is currently fourth, and many contestants in her position would have already given up. And while at first it really seems like it would be just an average throw, it actually follows precise physics: balance, angular momentum, and timing. And we can see that when the throw actually happens. And that moment is what determines the entire throw. Hello everybody, my name is Satumir, and if you're a sports fan and a mathematician like me, you've probably wondered how math ties into sports. Well, today I'm going to show you how mathematics explains one of the greatest discus throws in history. Tsvetanka Hristova's winning throw at the 1991 World Championships in Tokyo. This is not just a story about sport, it's a story about physics, mathematics, and precision. So who is Tsvetanka Hristova? Well, Tsvetanka Hristova was a Bulgarian discus thrower from Kazanlak and one of the best athletes in the world during the 80s and 90s. She became world champion in 1991, European champion, and later an Olympic silver medalist. She was known not only for her strength, but also for her exceptional technique and competitive mindset. At the 1991 World Championships in Tokyo, the women's final in discus throwing was very intense, and before her last throw, Tsvetanka was only in fourth place. With one throw remaining, she achieved 71.02 meters, more than 3 meters ahead of her competitors. That single throw won her the gold medal and she became a world champion. This moment represents not just victory, but the result of years of training, precision, and perfect execution. According to her trainer, the rotation of the body is very important, as well as the positioning of the hips in respect to the throwing arm. During the spin, the athlete builds energy, which is then transferred into the discus. The release is critical. It determines the trajectory of the discus. And interestingly, power alone is not enough. Technique plays an equally important role. So how can we describe this using math? Let's look at what happens after the discus leaves the athlete's hand. After the release, there is no longer any pushing force, only gravity acts on the discus. Its motion can be split into two independent parts: horizontal motion and vertical motion. Using this idea, we can model its path mathematically. For simplicity, we'll assume the only acting force is gravity. This means it has a constant downward acceleration. The velocity also splits into two components. Horizontally, the velocity remains constant. Vertically, it changes over time due to gravity. This separation is what allows us to analyze the motion mathematically. This separation is what allows us to analyze this motion mathematically. From these components, we can describe the position of the discus over time. Then, by eliminating time, we obtain the equation of the trajectory. And to make it look like an actual parabolic formula, we will also add the initial height from which the discus was thrown, because the athlete doesn't actually throw it from 0 meters. This equation shows us that the path of the discus is a parabola. This is why the throw follows a curved shape through the air. And here we can see a comparison between different throws on the graph. And we are focusing only on the first quadrant, using the x-axis as the field. The smiling face is where the discus is thrown from. The throw in blue color is the average women's throw, while the other two are Tsvetanka's. Actually, the one in purple is Tsvetanka's best throw, which was actually in Kazanlak, and it was around 73 meters. And we can see that both of Tsvetanka's throws are at a very low angle in comparison to the average women's. Notice how her throw reaches a much greater height and a longer distance. The distance of the throw depends mainly on the release velocity, as Tsvetanka's trainer said. In fact, it depends on the square of the velocity, which makes it the most important factor. The angle also matters, but less than speed, as we can see in the equation. In real life, throws are not perfect, but this model gives a very good approximation.
And so let's get a formula ourselves. Now here is a problem. Tatanka Christoph throws a discus from a starting height of 1.8 meters with an initial speed of 28 meters per second at an angle of 35 degrees above the horizontal field. Assume that the discus lands at the same height from which it was released. What is the formula for the trajectory of the discus? Well, now let's see the solution. We will try to get a formula that looks like this, which is a parabolic formula we just got. We will need the given values, which we got from the description, plus the gravitational acceleration, which is 9.81 meters per second squared, and we need to approximate the values of the tangent and the cosine, which are here in the parabolic formula. So we will evaluate the trigonometric values, and this is what they're approximately equal to. And then we can simplify the coefficient for x squared, which is around 0.00932, and substituting all of these, we get this equation, which is 1.8 plus 0.7002x minus 0.00932x squared.
And now, it's time for a little demonstration of my simulation.
So here is the simulation I made. As you can see, there is a stadium in the background. There are the parameters we can play with in the top right corner. Also, there is a top left corner with the formula and the parameters values. The thrower is in the throwing cage, and the yellow line shows the trajectory. When we press space, we do the little spin, and we throw 38.5 meters. Congratulations. And so this simulation is actually pretty good for beginners who want to see how trajectory changes when we change certain aspects of our throwing, and it can help them improve certain aspects and see how it changes the throw. And so why was Tatanka's throw a winning one, and what can be learned? As said by her trainer, rotation is important to build up speed in order for the throw to have more energy. Also, throwing angle was significantly smaller than other athletes, and at the end, it all comes down to the correct technique and undefeated mentality of Tatanka. And all of this can be analyzed or simulated in order to help beginners see their flaws and improve. So, Tatanka Kristova's winning throw wasn't just about strength. It was a precise combination of technique, physics, mathematics, and of course, mentality. Thank you for your time.